One, two, three.
Hi there! Welcome to the third episode of LIPPAD TV. Today, we will be talking about the radiation hazards in aerospace and outer space. These days, travel by air has been increasingly common for both business and leisure travels. But did you know that when you fly, you are exposed to radiation hazards? Flying in an airplane at an altitude of 8 kilometers would subject us to a 0.95 microsievert per hour of radiation. This value differs in duration, altitude, and latitude. Duration: the longer the flight time, the more radiation we experience. For altitude, the higher, the more radiation. And for latitude, the further north or south you are from the equator, the more radiation you will receive. This is a result of the Earth's magnetic field deflecting of the cosmic radiation away from the equator and toward the north and south poles. But is this value dangerous? Should we lessen our time traveling? Well, it just so happened that the radiation we experience when we travel through airplanes is less than the radiation we experience through our X-ray checkup. Thus, it is low enough that airplanes do not need radiation shielding. You might be wondering, what is a sievert? Well, sievert or SB is called a dose equivalent that measures the radiation that a human body can get. The dose equivalent represents a stochastic health risk. Sievert is a unit based on empirical data. A dose equivalent to 1 sievert means a 5.5% increase in developing a fatal radiation-induced cancer. Now, what about if you travel in space? Well, actually, traveling in space makes us more susceptible to radiation hazards. Radiation experience in space can be categorized into 3 sources. We have the solar radiation, galactic cosmic rays, and radiation contained in the magnetic belts of our planet. So what is solar radiation? Solar radiation comes from the star that is closest to us, the Sun. The Sun is usually pretty calm during solar events, such as solar flares and coronal mass ejections. Radiation from the Sun becomes extremely dangerous, especially if the astronaut is in the wrong place at the wrong time. Our Sun is young and produces only light particles, mostly protons and helium ions, which are easily stopped by the hull of the spacecraft. What cannot entirely be stopped by practical shielding is the high-energy electromagnetic radiation also produced in these solar events, more specifically, X-rays and gamma rays. The next source of space radiation we are going to discuss is the galactic cosmic rays, also known as the GRCs. GRCs are high-energy particles, chiefly protons that come from the remnants of supernovas. It is an ionizing radiation, meaning it has enough energy to alter molecules within the cells of our body, which may cause eventual harm once done again and again. Scary as it sounds, GRC is a dominant source of radiation that must be dealt with aboard current spacecraft and future space mission within our solar systems. In fact, together with other ionizing particles, astronauts in space are exposed to 50 to 2,000 millisievert of radiation. And imagine, 1 millisievert of radiation is equal to 3 chest X-rays. You may wonder, if too much exposure to GRCs is harmful to our astronauts, how do they protect themselves from it? For low-orbit missions, astronauts are protected by the Earth's magnetic field, and further on, they should use a form of lightweight shielding that mimic the Earth's magnetic field. From what type of materials? Well, that is still being studied until today's time. Last but not the least are the radiation contained in our magnetic belts in Earth, those that are contained in the Van Allen belt. Radiation belts can form around any planetary body that has a magnetic field. This belt traps protons and electrons, most of which originate from the solar wind. The inner belt contains higher concentrations of protons and heavy ions, and the outer belt consists mainly of electrons, which also fluctuates dramatically in response to the solar activity. Bad news aside, Did you know that Van Allen belts are also the cause of polar auroras? When belts overload, particles strike the upper atmosphere and fluorescence, causing the polar auroras. It is impossible to completely avoid radiation. In fact, radiation like the ones coming from the sun is a necessity to our daily lives. It provides heat, light, and energy necessary for all living organisms. However, it must also be remembered that even good things can become bad if they are excessive. Radiation from air travel are unlikely to cause risks to the human health. However, ionizing radiation from space can cause a lot of health hazards for our astronauts. Specifically, these kinds of illnesses are increased risk in cancer, diseases in central nervous system, and degenerative tissue diseases. So if someday you travel in space, remember to track your radiation absorption. So once again, this is your third episode for LIPPAD TV, and I say, don't forget to like and subscribe. Thank you.